Good morning, everyone. So in the last session, we started about the legacy class implementation. So in the collection framework, what are the legacy classes we identified first here? The first class we discussed here, vector. Vector is one of the legacy class because here, whenever the collection framework is introduced, the first class for this particular list interface, that is called vector class, is implemented, and later array list and linked list is implemented. So because of that, we are calling vector is one of the legacy classes. Okay. So to understand this particular legacy, what are the methods we identified? So we discussed some of the methods which are available under this particular vector class. Let me create a simple example of this particular vector related. First, I am going to create the packages. So this is the legacy package I created here, and here I am going to work with the classes here. Okay, so vector demo and the main method. Now, so what we can understand here regarding this vector demo. So yesterday we discussed about the different type of constructors. What are the different type of constructors we are having? Now let me create a vector, and here I am going to pass as a string because vector it is expecting object as a parameter. So the generic type basically it is expecting as a, it is not going to expect as a, what we can understand here. So key value. Okay, because list is going to store only object as a parameter. So whereas a map it is going to take as a key value plane. So this is the differences we already identified here. Now what I am doing here, so this is the vector I am trying to create here, and so new vector. What are the constructors we are having? Now if you remember, yesterday we discussed about the constructor. So this is the default constructor. The initial capacity, what is the value we are passing? 10. So what we can understand here, we can store the 10 values. Okay, so we can store the 10 records. So because of that, we are having 10 capacity. And the second constructor we are having, which is expecting the initial capacity. So explicitly we can provide the capacity and the increment. So capacity increment we are making as a 0. So how this particular capacity increment it is going to be work? So we see. So after that, this is the one more constructor which is expecting collection as a parameter. So collection as a parameter, and this is the last constructor, initial capacity and capacity increment. So what exactly the capacity increment will do? Here we are initializing this to the variable, but now observe this particular increment value, what it will do now. Okay, so what we are doing here? Now you can see what is saying here. You can read this. If the capacity increment is less than or equal to 0, in which case the new capacity will be tied to the old capacity. Okay, so what we are understanding is, so even if it is a less than 0 or if it is a less than or equals to 0, we are going to make the new capacity with a double based on the old capacity. So this is the capacity increment here. So whenever you are making it, so and based on the capacity, it is going to do the calculation. Okay, so this is the main important section we need to understand this regarding the initial capacity. Okay, so after that, so we discussed about the constructor. Now we need to work with the methods. So what are the specific methods we are having? What are the specific methods we are having? So to understand this particular specific method, because yesterday we discussed about the vector, internally it is implementing from the list entity. Now if you observe, this is one of the implementation class of this particular interface. So now you can see it is implementing this particular list interface. Whenever it is implementing, what we can understand here we can understand the list related methods. So what are the list related specific methods? Okay, list related specific methods. So these are these are the interfaces we copied here. Now you can see public interface list and which is extending from this particular collection. So now here we can work with this particular add method. So before going to work with this particular add method, we can copy the collection related method. We can copy we can work with this particular collection related method. So now observe here. Now you can see how many methods we are having. Add method which is coming from the collection, and second add method which is coming from the list interface, and add all method which is coming from the collection, and add all method which is coming from the list interface. So this add element, this is the legacy method which is declared under this particular class. Okay. So now if I am going to use this particular add method, so now we are working with the string here. So simply I am going to give as a 1 to 2. Okay. Now we need to understand how this add method internally it is implemented. So we need to understand how this add method internally it is implemented. Okay, let me comment on this. Now, so I am calling this particular vector. Here you can see public, synchronize, boolean, add method. Okay. So any method we are opening, the respective method contain the synchronizer, because these are the legacy methods. Okay. So now you can see what we are doing. We are calling the mark count here, and here you can see we are calling the add method, which is expecting the whatever the object we pass here, and element data. As of now, the element data it is not yet created, and element count is like it is a size. Okay. So element count and element data. If you go to the array list here, so basically this is the element data contain the object array, and in case of the element count, we call it as a size. Okay. The naming convention is different, but the purpose of this particular each and every variable will do the same. Whatever we observe under the list interface. Okay. Now go back to here. So add method. What we are doing is S. What is the S here? So we provided the size here. So what is the size we are having here? Now here you can see S we are having 0. So whenever we are having this particular S is 0, what we can understand here? Here we can understand the important section basically. Size as of now we did not initialize any record, so we are going to get as a 0. Okay. Now and here element data dot length. So what is the length we are having here? Now you can see 10. So why we are getting the 10? So this is the capacity. So this is the capacity. We can store only 10 elements. We can store 10 elements. Okay. Now what we can understand here, S basically 0 and length we are having 10. So it is not satisfied the condition. So whenever it is not satisfied, we are not going to call the grow method. Okay. And here what we are doing, directly we are initializing the value. So what is the element data? It is the object array. So if you remember, this is the object array. This is the object array. So this object array, directly what we are doing here, in the size currently is 0. In the 0 index location, we are trying to initializing the value. What is the value we are initializing? 1 to 2. Okay. So finally, vector and array list both are going to be stored in the object array. Getting it? So what is the difference here? Only the difference is synchronized. Only the difference is synchronized. So simply we are trying to return as it. So now this is the add method we have. So what about the another add method? What about the another add method? So let's say I am trying to initializing 1 here. The first index location I given, or if I am going to be stored as a second. So second index location 4, 5, 6. If you remember, index related method which we copy from the list interface. Okay, this is the specific method which we added only in the list interface. Now let me debug the same example. because these two methods we already discussed in the array list and the linked list, but we are discussing the legacy classes. Because of that, I am trying to discuss one more time. Now you can see, so this is the add method. Now here we pass the index. The index we given as a 2 and element we given as a 4 or 6. Now here insert element x. Insert element x. So this is the method it is calling internally. Now, so if we go to this particular insert element x, what we are doing here we are passing the object and we are passing the element. So index. So now you can see index. So what is the index is 2 and what is the element count we are having 1. Okay. So whenever we are trying to work with this particular index here, so what we understand here in the array list and the vector classes, so within the size only we can update the value. Within the size only we can update the value. Okay. So we cannot update the outside of this particular size. So whenever we are trying to update here, now we are going to get this particular exception. So now if you see this, what is saying here we are getting array index out of bound exception. Because here, so index is greater than compared to this particular count. Count means size. So size we are having only one record, but we are trying to insert in the second index location. Okay. So same behavior. Array list also will do the same behavior. So now we understand this. So 2 greater than 1. 2 greater than 1. Now what we can do? So here, so we need to work on the first 0 index location. Even if you work with 1, let's see what happens. So I provided as a 1. Okay. Now again, I'm trying to run the same example. Now you can see insert element. Now here, what we can understand here, so index, what is the index we provided? 1 and element count also 1. So now we are not going to get any exception. So we are coming out of this element count, that is called size, and here, so this dot element data, currently whatever the element we are having, we are trying to store into this particular element data, and we are checking this. So the particular size and capacity is not going to be matched here. What we are doing is we are copying it. Okay, we are copying it. So all the data we are copying into this particular element data. Now currently, what is the record we are having? In the 0 index location, 1, 2, 3. Now what is the index we are having? 1. In the 1 index location, what we are going to do? We are going to store the 1 more record. So now you can see 0 and 1. Getting the point. So what you understand here, whenever we are trying to work with this particular index related operation, so greater than the size we cannot give. If you are trying to give the greater than the size, now we get an exception. So what type of exception we are going to get? So that is a simple understand array index out of bound exception. Array index out of bound exception, the size is greater than the size, like the index greater than this particular size. So this is we'll get it here. Now after that, if I'm trying to print this, okay, so if I'm trying to print this particular vector, what are the objects it is going to be printed? 1, 2, 3 and 4, 5. So 2 records we inserted, the 2 records are loaded. Okay, so the one method, like one add method which we discussed from the collection interface method, and the second add method we discussed the list interface method. Okay, so same way it will work on the add element. So finally, what is the method we need to work here? Add element. So this is a specific method. Now what I'm doing here, so I'm trying to pass this particular 799 here. Now we need to understand how this particular add element it is going to be implemented. Okay, so this is the add element here. Now you can see, so synchronize add element we are passing. Synchronize add element we are passing. Now here, what we can understand here, what we can understand here we can understand the important here, whenever we are calling add method or whenever we are calling add element method, so internally it will do the same. Internally, so this is the method it is going to be called. This is the method it is going to be called. Okay, so this is very important, we need to understand it. Now if you observe carefully, If you observe carefully, so where we are having add method. Let me go to the top here and search the add method. Okay, so now if you see here, this is the add method, synchronized boolean add method. So this add method basically, it is coming from the collection interface, so we implemented it. But internally if you see, what is the method we are calling? Add method, element we are passing, and the object array we are passing, and size we are passing. So this is the three method. So currently whatever the add element method we are calling, so this also is doing the same, but only the difference here, it is not going to return any value. It is not going to return any value. So this is what we need to understand. Only this is the difference we are having. So now you can see element to data dot length. So size and element to data, both we are going to have different. Now you can see element to data S. What is the S? Size here. In the which index location we are trying to store? Second. And what is the value we are having? 719. So finally, based on the size, we are trying to store the record in the specified index location. So now you can see 1, 2, 3, 4, 5, 6, 7, 19. Okay. Now finally, what you understand here, add element and collection framework add method, both it is going to do the same implementation, but only the one difference here, the collection interface add method will return true if the record successfully added, but the add element method, it is not going to be return any value because it is a void. So this is we need to understand. Now, so what about this particular get method? So this is the legacy method basically. Add element basically is a legacy method. So these two are the collection method, collection interface method, and list interface method. So when in the 1.5, basically in the 1.5 the generic is introduced. So whenever the generic is implemented to the legacy classes, the entire code is reconstructed. Okay, so the entire code is reconstructed. So this is very important. So now it is fully compatible with the collection. It is fully compatible with the collection. So you can work with any method. So even the specific methods are available in listers, all common methods are available in the collection. Everything you can work with this particular vector class. Only one difference, all the methods we are going to have implementation. Okay. So now you can work with the remaining methods like so remove method, contains method, get method, getting the point. So clear method, everything we can work with this particular vector class. So try to work with the remaining method regarding this particular vector class. And let me know if you are having any questions regarding this particular all the list interface and the collection framework method with the vector class. So whatever we discussed earlier. So if you see here, we discussed the add method, add all method, and list iterator we discussed here, and these are the iterators: equals method, hash method, contains method, index of method, size method, is empty, clear method. Okay, so these are the methods also. Now you can work with this particular vector class. Okay, so try with the each and every method how it is going to be implemented internally. So this is the vector class implementation. Now, so we are having specific methods. What are the legacy methods we can call? So these methods basically not available under this particular list or collection entity. What is the method? The first method we discussed, add element. Now what about the second method is a capacity. Vector dot capacity. So this capacity basically it is not available under the list or the collection entity. Okay, so this is a specific method, or we can call it as a legacy method. Now what exactly it is doing is the capacity. Now it will try to return the how many objects we can store into this particular vector. So now I'm trying to print this particular capacity. Now you can see 10. What is the value we are getting? 10. So what we understand is we can store 10 records into this particular vector. So once the 10 records are filled, what we will do basically, it will do the capacity increment. So basically the vector class it is going to have dynamic array. So basically this particular vector internally it is going to be growable automatically. Here also we are not going to write any logic. So whatever the logic we observe for this particular array list here, the same logic also it is available for this particular vector. Okay. So because of that, based on the capacity, it will do the calculation and it is going to be increase the capacity. So this is the observe. And another important method, clone here. So clone means what we are going to do basically here. Clone method. So clone basically it is going to be give the duplicate vector object. It is going to give the duplicate vector object. Okay. So something like here, whenever I'm trying to clone this, it is a one more object we are going to give. One more object. Let's see. If I'm trying to print this particular clone here, so now you can see 1, 2, 3, 4, 5, 6, 7, 8 capacity pin and original. So clone means basically what is doing? It is trying to copy the one copy of object, the vector class object, into the another object. So this is the one. So using the original class object reference, we are calling the clone method. So internally, whatever the information we are having, the respective vector classes, now it is going to be copied and it is going to create a new vector object and it is trying to assign as a new variable class clone. So if I am trying to print this, so we are getting the same. So clone will do the clone basically what is done, just it is going to copy the one object of this particular vector class. So this is the legacy method. It is not going to have in the list interface or connection. Okay, and here contains. So contains basically where we are having contains here. Okay, so I think contains it is not a legacy method. It is also available in the selection. And so basically we are having element at. Element at basically vector dot element at. So element at basically what we can understand, it is a similar method get method. Okay, in the list we are having a get method. So now if you see get method where we are having, this is a get method. What we are doing is we are providing the index here. We are providing the index and it is trying to return the e. And this element at method, what is returning basically, it is also will do the same. Okay, only the difference here, name of the method is changed. Name of the method is changed. So element at, if I am going to give as a index 2, if I am going to give as a index 2, what exactly it will do now? It is going to copy the the element at, based on the second index location, it will copy the whatever the value they are having, it will load the value and it will. Now you can see 796. In the second index location, we are having this particular 796. So this is we can understand it. Okay, this is the same purpose. Like get method, how we implemented, same way it is implemented, but only the name of the method is changed. And another important here, vector dot elements here. Vector dot elements. Now if you see here, the elements here we are calling the enumeration. Okay, enumeration. So basically we did not discuss about the enumeration here, but we know the iterators. We know the iterator and the list iterator, but we don't have the information regarding this particular enumeration. So basically what we can understand here, enumeration is one of the legacy interface. How we discuss about the iterator and list iterator, the interfaces, same way enumeration basically it is also one of the legacy interface. It will do the same behavior like next element, hash next, hash previous, and previous. So whatever the method we discussed here, so same way here also we are having as more element and the next element. Okay, and this is one of the default method as a iterator. As a iterator. So because here what we are doing, here we are calling the new iterator and we implemented the as next and the next. So if we want to work with the iterator, you can call this particular default method. But otherwise you can work with the enumeration. So these are the two abstract methods. If you know, let me add iterator also. Vector dot iterator. So now what exactly the iterator is doing now? Now you can see the iterator. So as next and the next. We know this two because we already discussed. And here, so we are having a remove method. And you can see the one more for each remaining. So we already discussed here. So for each remaining also will do the same behavior of this particular iterator. Okay, but what you need to understand here, so here if you understand the differences, if you understand the differences here, now enumeration iterator, so same expecting the generic, and here we are having as more element, but here we are having as next. Okay, name of the methods are different. So now you can see next here. So here we are having next hidden file. So here initially, so we used to work with this particular enumeration, but here this iterator when it is introduced from the 1.2 version. So whenever the enumeration is coming from the 1.0, like in the initial stage when the collection framework is introduced, so we used to work with the enumeration. So this is one of the legacy, the iterator interface. So this is it is not a legacy. So till now we are going to work with this particular iterator. So only this is the differences here. Only this is the differences we are having here. Now observe here. So what exactly it will do the enumerations and vectors? It will do the same behavior. So now while you can add here and you can write the elements dot as more elements here, and if you are having this out here, as next. Same way. So while I'm going to write here, iterator dot has next here. Without what we are having, iterator dot next. So not has next here. Next. Okay. So now I'm going to do the both examples. It will do the same behavior. Now you can see 797 1 2 3 4 5 6 is 1 and 797 1 2 3 4 5 6 2. So iterator and enumeration both are doing the same here. So let me print one empty line here. Okay, so that we can differentiate these two. Here we are having element S. Now we'll understand this thing. Now you can see 1 2 3 4 5 6 7 8 9 and 1 2 3 4 5 6 7 8, and this is the object we are passing because of the last line number 20. So enumeration with iterator both are going to do the same, but only the difference is enumeration is having basically it is a legacy interface, but iterator it is not a legacy. So now if you see this, where we are having, so instead of checking this, so we'll go to the vector class, copy this and go to the vector and try to find out this. Okay, so here we are having, so this is the enumeration. Whenever we are calling the element, we'll call this particular enumeration. What we are doing is new enumeration we are doing. So new enumeration basically it is an interface and directly we are implementing the method. So now has more elements, what we are doing is count less than element count. Okay, and here we are doing the synchronize. Here we are doing the synchronize. So same, if you see here, this is line 370. If I am going to call the next method, if I am going to call the next method, now you can see it is also having the same synchronize. So this is the boolean as next, and this is the next method. So now you can see here we are having private class itr, which is implementing the iterator. So here both will do the same behavior, only one is a legacy interface, one is not a legacy interface. So this is, we need to understand it. Now we observe this. So after that, what are the methods we are having? Now here, ensure capacity. So ensure capacity, basically it will do the incrementing the capacity. Okay, if we want to add a capacity here, what we can do? We can call the method called now you can see ensure capacity. So let's say if I'm going to give 25. If I'm going to give 25, so what exactly it will do this particular ensure capacity. Okay, now I'm calling the ensure capacity. Now if you see minimum capacity, so what we provided 25, and it is a greater than 0. So mod count we are implementing, and here what we are doing. So if the minimum capacity is greater than the current length. So what is the current length we are having? 10 years. Current length we are having 10 years. Okay, and the minimum capacity we are having 25. So whenever we are having 25, what is this? Simply it is calling the grow method. So it will try to increase the capacity of this particular vector. Okay, so now if you want to read this, now go to the grow method, and what we are doing, we are calling simply array copy, and here we are going to call the new capacity. The same logic we implement. This also, if you go to the array list here, this is the same code it is going to be implemented. Array list dot copy of, and the new capacity is something copy of. So same we are going to have. Okay, so this is, we can do the same, but only explicitly we can have a increasing the capacity of the respective vector class. And here another important method called first element. Now, so what exactly the first element is doing? So it will try to load the first element of this particular vector class, because internally vector it is going to be use the object array to insert the record and to load the record. So if you see, if the element count is 0, now we'll get an exception. Otherwise, what we are doing is element data and index. So carefully observe, what is the index we are passing here? 0. Okay, so simply here we are providing the index. The index is going to be placed like 0, it is going to play as the index role, and this is a object array. So this is a object array. Now you can see 1, 2, 3, 4, 5, 6, 7, 8. In the 0 index location, what is the value we are having? 1. The value is going to be returned. Okay, so it's a simple understanding. So same way, so we are going to have last index. Same way, we are going to have last index. And so vector dot last index, last element we are having it, so we can load the last element. And along with this, what is the other method we are having it? Vector dot insert element. Now if you observe carefully, vector dot insert element. So whenever we are having this particular insert element, basically what we are going to do here, so whenever we are going to do this particular insert element, it is a similar method of set. So you can see here what we are having. Here we are providing the index, and we are passing the element. Okay, so here also this method also it is going to be expect same here. This method also now it is expecting the same behavior. Now you can see object and index. but only the difference is here we are passing index and later we are passing the object. Parameters order is different, but so parameters are going to do the same. So let's say I given as a 2 and here are object, right? The object I want to give as a 159 and here I'm going to give as a second index. So what exactly it will do here? Based on the second index location, it will update the value. Just it is going to update. It is not going to insert the new record. So now if you see this, so this is the insert element here. What we are having? Index. What is the index we provided? 2. And element count 2 or 3. So the size we are having 3 and index we given 2. Now more than this particular element count here, what we can understand is, so this particular exception we are going to get. This particular exception we are going to get. But currently, index, it is not greater than this particular element count. Element count means size. So simply, we are can update the value. So now you can see this is the element data and we are taking the length here and we are copying this. And finally, what we are doing here, so index, what is the index? Second. And what are the second index location value we are having? So second index location 789. The 789 now it is going to be replaced with the 159. So second index location now it is going to be replaced with the 159. Now if you see this, so 0, 1, 2. So in the second index location, what is the value we are having? 159. Okay. So this is, we need to understand the regarding this particular. What is the method we are working? Insert element. So directly we can insert the respective element in the given index location. Okay. This is what we need to understand. Like we are going to have some similar methods we are having here inside the vector class. So try to review the each and every method. Try work with so multiple examples so that we can understand the what are the advantages and disadvantages we are going to get compared to this particular array list and the linked list. Okay. So this is the implementation of this particular vector class. So any questions? Okay. So now if you don't have anything here, now we need to discuss one more important class. Okay. So this is also one of the legacy class. So what is the class we are going to discuss here? Stack. So stack basically it is a subclass of this particular vector. Stack is a subclass of this particular vector. So what exactly the stack will do now? Okay. Now if I am trying to explain this particular stack, this is the stack here. Now you can see it is extending from this particular vector. So whenever it is trying to extend from this particular vector, now what we are doing is we are having a push method. So what exactly the push method is doing? It is calling the add element. So just now we discussed the add element. Now here we are having pop method. So what exactly the pop method is doing? We are loading the size method, like we are calling the size. The size it will try to return the how many objects stored into this particular current object. Now after that, so what we are doing? We are calling the remove element. So remove element based on the length minus 1. So simply it is trying to remove the 1 by 1 object. It is trying to remove the one object based on the length minus 1. So this is a peek method. So what is it? Simply it is trying to return the element. Pop method, after removing the respective object it is returning. The peek method, it is not removing the object. Simply based on the size, it is loading the object and the respective last index value, whatever we are going to have, the particular value we are changing. So basically, if you observe last in first out, whenever you are calling the peek method and pop method, we are loading the last record. We are not loading the first record. So this is This is what we need to understand regarding this particular stack. Okay, so what you need to understand regarding this particular stack is simple understanding is, so stack basically it is a subclass of this particular vector, and internally it is provide the last in first served behavior. Okay, along with the stack it is going to have a default constructor. Only one default constructor it is having, and here we are having generic behavior. So whenever we are trying to work with this particular generic behavior, what we can understand here, so all the generic classes we can use and we can work with any data type. Okay, so let's observe the simple example of this particular stack. To understand this particular stack here, what I am doing is I am going to create one class with stack demo, and here I am going to work with the main method. So here we are having this particular stack here, and every time we are working with the string, right? Now we can go for the integer. So stack here, now default constructor. There is no additional constructor. So now stack dot, what is the method we can call here? So add method. So this add method is coming from the way, let's say if I'm going to give 4, 5, 6. Let's say if I'm going to give 4, 5, 6. So now you will understand which method it is going to be called, add method. So simply I'm calling the add method. Now you can see, now we are under the, okay, this is the integer. We'll go to the one more time. Now if you see this, now if you see here, what we can understand, we are not in the stack class. We are not in the stack class. Now we are under the vector class here. So why we came to the vector? Because stack internally it is extending from the vector. So whenever it is extending, all the superclass functionality we can access into the subclass. Okay, this is one of the important concepts of inheritance. We already discussed in the initial stage. So now, because of that, we are able to access the add method. But as of now, add method it is not available under this particular stack. So there is no add method. So what are the specific methods we are having under this particular stack here? So only the specific method, it is a push method. So we can copy the push value something like a 1, 2, 3. Now, what exactly the push method will do now? What exactly the push method is doing? So here you can see, this is the push method. Now we are under the stack class. So what method we are calling? Add element. Okay, add element we are calling. But here, so there is no add element. So which class method it is going to be executed? Vector class add element. Okay, so just now we discussed the vector class related methods. Vector class related method. So now no need to discuss about this add element. So simply after adding, we are getting this particular element. Okay, so this is a stack example. So now what I am doing here, I am going to call some multiple records here. Okay, so 1, 2, 3, 4, 5, 6, something like 7, actually, and 1, 4, 7, 2, 5, 8, and 3, 6. So these are the records we are having. Let's say if I am going to print this. If I am going to print this particular start. Now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever the record we inserted, we are getting. But the stack also internally, it is trying to use the object. This is important. Stack also internally, it is using the object array to insert the record. So this push method, it is trying to insert the record. So what about the other method? So now stack dot pop method I'm calling. Okay, stack dot pop method. So now I'm going to be print this particular pop method. So what exactly the pop method will do now? What exactly the pop method? So what about the 369? Okay, what about the 369? So this is basically, it is the last record. It is basically last record. So we loaded the last record. But if you observe carefully, the pop method basically it is remove the last record. It is removed from the stack of this. So now if you see this, okay. So basically, so what is exactly the pop method is doing is the pop method basically it is trying to remove the last record, and whatever the last record we remove, the last record we are trying to print. The last record we are trying to print here. So this is the main purpose. So mainly what we can understand is, so remove the last record. Okay. So the whatever the last record we remove, that is trying to return. So this is what we need to understand here. And another important section basically, what is another method we are having? Peak method. So let me comment out this. Let me comment out this particular pop here. So I want to go for the peak method. So start dot peak method. So what exactly the peak method will do now? So the peak method basically without removing the last record, it will simply return here. Okay. So if you want to know the shortcut to initialize the variable, so Control Alt V. Okay, Control Alt V. So you can use the plus Alt plus and V. So this is the shortcut we need to use to initialize the variable. So now after that, what I am doing is, so here I am trying to print the peak value. So what exactly we are doing basically, so now I have to understand the differences between pop method and the peak method without removing the last record. Okay, without removing the last record, so simply we are getting. But whereas this particular pop method, it is going to remove the last record. Whatever the last record we remove, so the record it is going to be printed, like it is going to be written here. So this is the difference. Only three methods we are having, like push method, pop method, and peak method. So if you want to search any element, here, so what we can do, we can search we are having one method called dot search. Okay, dot search. So I want to search the 369 record. I want to search this particular 369. So what is written in this? So simply it is going to return the positive value. Like we can understand the index location. If the given number or given object it is not available, we'll get as a -1. So let's say if I'm going to print this particular search here. If I'm going to print this particular search here, what exactly it will do? The 369 is reside in the which index location. So now you can see it is trying to return as a 1 here. So these are the peak related. Okay, 369 is trying to print because of the peak method, and here we are doing the search operation. So what exactly the search operation will do now? What exactly the search operation it is going to do? So let me go for the internal implementation of this particular search operation here. Now you can see what we are doing here, last index. Okay, if you remember the index of and last index of, what exactly it will do? Last index of basically it will do the reverse order. From the last record it will try to keep unloading the record. So because of that only we will call it as the stack. Basically internally it will work last record. Okay, the last record we are going to load as a first. So this is what we need to understand regarding this particular vector class and a stack class. So any questions? Still anyone having any questions here? Okay. So it's a simple to debug the any application. So let's say basically what I did here I put a breakpoint, line number 80. So because I want to know the internal implementation of this particular search. So whenever we want to debug the particular search, because search is a method. So inside the method, whatever the logic we implemented, so that is we want to see. So now in that case, what we can do, so we need to go to the step into. We need to go to this particular step into it. So whenever we want to go to the step into, so which type of keyboard we can use, like the shortcut here, this is the one. Okay, Alt Shift F7 or you can use, otherwise you can click on this particular Z1. It will go to the step into it. Okay, so now I reach to the line number 88. Now just click on this particular step into. Now we are under the, so because we are working with the integers, so here it will call the value because here it will try to create an object of this particular integer first. So come out of this because we come with a different method, value of method we reach. So now whenever we reach another method, what we can do? So either you can click on the step out or you can click on the next here. So next, basically this particular arrow, what it will do, this particular arrow basically what it will do, it will keep on execute the line by line. It will keep on execute the line by line. Let's say here we are having method here. Here we are having method. So the method again it is going to have some different line numbers. So once we enter into this specific method, we keep on execute this line. So after that, what happens here? It will come out of the particular method. After executing this particular 3 lines of code, it will come out of this particular method. After that, it will keep on executing this line by line. So this is the main purpose of this particular step. What is the shortcut? I think step 8, I guess. Yeah, F8. Okay, so don't here just click on this particular arrows so you can easily understand the debug. Otherwise, click on the shortcuts F8 to F9, F7, something, whatever they are having here. Okay, so this particular arrow basically it will keep on executing line by line. So now this particular arrow and this particular arrow basically both will do the same, but sometimes here this particular arrow it is not going to provide the much important information. Then you can use the red color. Okay, so step into. So now come out of this. Now we are under the value of it. So I came out of the same method wherever the search. So still now we need to go to the search. Click on this particular step into. Now we are under the search. So here last index. This is the one more method. Now if you want to see the internal implementation of this particular last index, again you can click on this. Again you can click on the particular step into. Now if you see, this is the one more method. Last index of which is expecting the 2 parameters. So again if we want to go to this particular internal implementation, click on this. So now we are under the last index. So now here there is no method here. So there is no specific method. Okay. So if you want to go to the constructor calling, again you can click on it. But in our case, it is not satisfied the condition. So what we can do? Simply click on the line by line. So simply click on the F8. You can click on the F8. So here, if condition, else condition we are checking. Now here we are having a method. Here we are having a method called equals. So if you want to go inside the equals method, so again you can click on the. Again you can click on the. So step into. Now we are under the equals method. Now we are under the equals method. So we are checking some logic here. So based on the condition, the value it is going to be returned. So now we come out of the equals method and we are returning the I. And we are returning the I. So what is the I value? Index we are trying to return something like a 369. So now we are coming out of the last index of. So one more last index we are having. Now just click on the next line. Okay. So finally we got as the I value 5. So we debug the last index of method and internally we debug the equals method. We analyze how it is implemented. So finally we got the I value as a 5. So now if the I value is greater than or equal to 0, simply it will return the size. So now if we want to go to the size method. internal implementation of the size. Again you can click on the stepping. So now you can see this is a element count. So currently the size method, it is trying to return the element count. Okay. So what is the element count we are having? 6. So the same 6 it is written. So now in place of the size we can add as a 6 minus I. What is the I? 5 value. 6 minus 5. So we'll get as a 1. We'll get as a 1. So that is a 1 value now we are getting. Okay. So this is the way we can debug. Any question? Okay. So if you don't have anything now, so we need to discuss about the another important legacy class called dictionary. So dictionary basically it is one of the abstract class. So it is going to provide the 369 basically it is not going to be stored in the index 1. It is going to be stored in the last index. But here what we are doing basically, the stack it is going to cover with the last in first out. Last in first out. The 369 is this record is stored in the last index here. So it is picked by the first value. So if you observe carefully, these values are going to be stored like this. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 4, 7, 2, 5, 8 and 369. So if you observe, so basically indexes 0, 1, 2, 3, 4 and 5. So these are the indexes. Okay, if you remember the object array, how it is going to be stored, like these are the values we are going to store in the stack here. So now what we are doing, whenever we are calling this particular search here, which method we are calling? Last indexer. Okay, last indexer basically what it will do, from here to here it will do. Okay, so this is something like last value we try to pick as the first record. This is last indexer. Whereas the indexer method, now it will do the reverse indexes. So 0 to 5 will do, and here 5 to 0 it will do. Okay, 5 to 0 it will do, because here we are calling the last indexer. What is the object we provided? Here the O, it is trying to work with the 369. We given as a 369. In the search method, we given as a 369. 369 is the last record. Now, what is doing basically? If you go to the internal implementation of last indexes, so here we are passing object and element count. What is the size here? The size we are having 6 and the size minus 1. Size minus 1. That is become 5 here. So what we are doing here? Here, index is 5. This is the object we are having 369. This is the object we are having 369. Now what we are doing? If the index is greater than this particular element data, so it will throw an exception. The element count we are having 6, but the index we are having 5. So this exception will not. Now after that, what we are doing? If the object is null, this is the logic. In our case, object is not null. So here we are going to use this. So now you can see what is the I value we are doing. I value we are doing as the index. What is the index we are having? 5. Okay. So currently 5 there. Now here I greater than or equal to 0 and we are doing the I minus 1. If you remember, whenever we are decreasing the value, we are doing the reverse order. Whenever we are increasing, we are doing the natural order. So this is we already discussed when we are trying to work with the arrays example. Okay. But here I value how much we are having? 5. What we are doing? Element to data. It is the object array. What is I value? 5. In the fifth index location, what is the value we are having? So the value we are having 369. Okay. In the fifth index location also we are having 369. The object we pass as a 369. The O also we pass as a same. So whenever we are passed here, what happening basically? So here I value we are writing. What is I value? So we find out the 369 is available under the fifth index location. Okay. So now currently also it is available in the fifth index location. So now the last index of method currently it is trying to return as a 5. So now observe carefully, it is returning 5. Okay, so here you can see the I value. What is I value we are going to get here? Here we will get as a 5 here. Now once we get what we are doing, if the I value greater than or equal to 0, so it will satisfy. Now again we are calling the size. So size is 6 we are having. 6 minus 5. 6 minus 5. Now what happening is we are getting as a 1. Getting the point? Here because of this particular logic, now we are getting as a 1. But actually the 369 is resides in the 5th index location. 5th index location. Getting the point? So this is the search. If you are going to do the reverse here, if the 316 we are having multiple times, this size will do the difference. Okay, here the search will do the different operation. So what we can understand basically here, so the 369 we observe in the first index location, like first time only we found out. In the first time we found out, so we are returning the first time. If it is finding in the second time content, so the search result it will be different. So finally, what we want to understand here, whenever we are trying to work with this particular star here, it is doing the last in first term. If you observe, pop method also will doing the same. It will try to find out the last record, and the preach method also is doing the same. It is try to find out from the last record it will come. And again, the search also now it will try to find the last record again. So in the last, so it will try to find out the first record. In the last, we try to find out the first record again. So this is what we need to understand. So in the first record we have the 369, that is we are trying to return. So let's say, so I am going to provide the one more record. So if you understand carefully, I am going to provide the one more record. Okay, so here I am keeping as this particular diagram, but now go to the search here. In place of this 369, I am going to give 1 to 3. I am going to give 1 to 3. So same example you can run in the debug mode. Now you will understand. Click on, we reach to the search here. Now again I am going to be last index of we are having, last index. Now if you see, index we are getting as a 5. Okay, because from the 5 we are going to load the 1 by 1 here. Now you can see, so we will come to the else block. So now you can see, index we are having 5. Index we are having 5, like I value we are having 5, index 5, I value 5. So what we are doing, what is the O we given? The O we given as a currently 1 to 3. Here you can see the O we given as a 1 to 3, index we are having 5. So here in the element data I, what is the element data I? I value we are having 5. So now you observe what we are doing here. So 1, 2, 3 equals, we are passing 369. Getting the point? Because index value we are having 5. So whenever we are having 5, we'll try to load this particular record. Okay, this record we are loading. So now it will not satisfy because 1, 2, 3 and the 365 both are objects are not equal. So now if you see carefully, if it is equal, this value is. Now if you see carefully, not satisfied. So second record, 4. I value 4. I value 4 means this is the 4th. So 2, 5, 8. It will not satisfy. It will not satisfy. Okay. Now 3. What is the 3? So 1, 4, 7. It will not satisfy. Now 2. What is the 2? 7, 8, 10. It will not satisfy. 1, 4, 5, 6. It will not satisfy. Now it will satisfy. Now it will satisfy. So what is the value it will satisfy here? Something like 0. So whenever I value reaches to 0, now this particular record is satisfied. So now you can see what is the value we are returning? 0 we are returning, because so in the 0 index location only we given 1 to 3. Now it is satisfied. So now the last index of it is trying to return 0. Currently you can see I value 0. Now whenever the I value 0, what we are doing? If the I value greater than or equal to 0, so whenever we are having, so 0 greater than or equal to 0, it will satisfy. It is satisfy the 2. Okay, only it will not satisfy 0 greater than 0. So this will become false. This will become false, but in our case, it will try to return as a true. Okay. So now it will try to return as a true. So whenever it is trying to return as a true, so we need to understand now. We need to understand what is doing here. So now you can see size is. What is the size? Size will get as a 6 here. Size will get as a 6. So 6 minus I value. How much we are having? 0. How much we are having? 0. So what is the value we are going to get now? Now what is the value we are getting it? Now you can see such. What is the value we are getting? 6. Now what you understand here? What you understand here? So this is the last value. This is the last value we got it. So simple understand here, it will do the last two first. Simple understand here, it will do the last two first here. While doing the last two first, if the record is matched, the specific index location it will return, and we can understand it. So the particular record is available in the specified index location. So this is only the differences we can understand, because the 369 it is coming as a first, and the 123 we provide as a last. Okay. As of now, how many records we are having in the stack is 6 records. The last record we find out 1, 2, 3, because we are doing last to first iteration. Okay. So is it clear? So still any questions? Okay. So 2 more classes we are having. So the 2 more classes we'll try to discuss in the tomorrow session. So once we complete this, mostly we'll try to complete the entire collection framework. Okay. So we'll continue tomorrow. So we'll try to complete the 2 legacy classes. So mostly we'll complete tomorrow. So after that we'll start the spring related example. Okay. We'll continue tomorrow.